SwayamPrabha. Digital India. Educated India.
Hello and welcome to the course on manufacturing technology theory and practice. Now, this is the lab part or the hands-on training, as we call, to the students through the online course. Initially, we have shown you, we have given you the theory of the conventional machines, of the unconventional machines, the numerically controlled machines, and so on. Now, we will give you an introduction to all these machines and the equipment that we have gone through in the lecture part in the laboratory. We will show you, we will demonstrate the equipment, demonstrate the tools, conventional metal cutting machines. Unconventional machines we will not be demonstrating as such, but we will demonstrate and show you the working principle of the numerically controlled machines. We will show you how to program, as we have discussed in the theory part. Now, before we go to the lab, let me give you an introduction to the transmission, to the manufacturing and the fabrication of the gears, to the tools that you can encounter in the lab, and to the numerically controlled machines, how they can be operated and how the part programming can be made. So, first of all, I would like to tell you about the power transmission, which is one of the most important aspects, one of the most important factors in any machine for that matter. Now, in any machine, as you understand, that the power has to be transmitted from the input to the output. What we mean by input is the input shaft, which is connected to the main drive. Let us say in case of automobile, here we have the internal combustion engine, and the input shaft or the driver shaft that we call, it is connected to the output shaft of the internal combustion engine with a coupling, the help of a coupling, and the power from the internal combustion engine is transmitted to the input shaft. Now, from the input shaft, this power has to go to the output shaft in a manner that there is minimum loss in the power, that is one thing, and in case we have to increase the speed, decrease the speed, increase the torque, decrease the torque, that we have to make it through the transmission. As you understand that in case of automobiles, for example, here we have a gearbox, or for that matter in a machine tool, we have a gearbox, and through the gear train we make the transmission of the power, of the torque, and this transmission is not only through the gear transmission. Okay. There are different kind of transmissions, and I will show you some of those transmissions in the slides. So, the power transmissions, as you can see, first is the belt drive. As you can see here, in this belt drive, one of them is the input shaft. This is the input shaft. On the input shaft, we have the pulley mounted, and from here to the output shaft, on which the the pulley is mounted. So, the transmission will be from here to here. All right. So, now let us see how this can be made. So, as I told you that here is the belt drive. As you can see that this is the input shaft. On this input shaft we have the pulley, and to the output shaft, let us assume that this is the output shaft. On the output shaft we have another pulley mounted, and the rotation the power is transmitted from the input shaft here to the output shaft through this belt drive. In this you can see that here is the same arrangement as the previous one, but in this case we have a cross belt. All right. Now, the straight belt and the cross belt, these are provided to transmit the power from the input shaft to the output shaft, but in the straight belt the rotation of this pulley and this pulley will be in the same direction, whereas for the cross belt the rotation will be in different direction. Let us look at it, let us see how it can be done. As you can see now, the rotation is, or the power is transmitted from this pulley to this pulley, and they are rotating at the same direction because it is a straight belt here. And in this case, here we have the cross belt. All right. In case of straight gear, as you can see that these two pulleys are rotating in the same direction, and in case of the cross belt, if this pulley is rotating in this direction, the another pulley is rotating in the opposite direction. So, that is why we have the straight belt and the cross belt. Now, in the here as you can see that transmission is through a belt, and the belt is sitting on a groove of these pulleys. All right. So, therefore, here of course, if the torque carrying capacity is very high or torque is applied is very high, in that case there may be a possibility of a slip, meaning that if the torque is very high, in that case if they are not capable of transmitting, then the belt will slip on the pulleys. All right. So, therefore, these are the transmissions which are not actually the positive drives. Now, here important thing is that, as I was telling, that the transmission ratio. So, if you see that both are rotating almost at the same speed, because the diameters of both of these pulleys is roughly the same. Now, to have the more transmission ratio of the drive, in that case the diameter of this pulley, if it is bigger and the diameter of the input shaft is small, output shaft is smaller, in that case the output shaft will be rotating at a higher speed than the input shaft is rotating, as you know that, and vice versa when this will be a smaller diameter of the pulley and this is bigger diameter. So, the transmission ratio is less. So, therefore, the transmission ratio is determined by the ratio of the diameters of these pulleys, input divided by output diameter. Now, the next mechanism, that is the for transmitting the power, is the gear drive. However, here you can see that the gears are bevel gears, and these teeth of the bevel gear are cut at an angle. Let us say this is the input shaft on which the smaller gear is mounted, and this is the output shaft where this red color gear, bevel gear, is mounted. So, when we rotate them, as you can see that during the rotation, this pulley, which is this gear, which is the input gear, this is transmitting the power to the output gear. All right. And here also the transmission ratio is given by the number of teeth of the input divided by the number of teeth of the output. So, accordingly, if your input gear is smaller and the output gear is bigger, in this case this shaft will be rotating at a less RPM than the input shaft, and vice versa. If this is bigger, this is smaller, then it will be rotating at a high speed, as you understand. This is the same thing as in case of the pulleys that we have seen in the earlier mechanism. Now, the next mechanism that you can see here is the chain and the sprocket mechanism, and the chain and the sprocket mechanism is similar to this belt drive mechanism. Only thing is that here the transmission is between the two sprockets, or this is one sprocket which is mounted on one shaft, and this is another sprocket which is mounted on the another shaft. So, this must be familiar to all of you, because this is popularly used in the bicycle. So, in the bicycle you are pedaling, and this, in that case, the pedal is connected to this shaft, which is considered to be the input shaft, and the power that you are applying to the input shaft is transmitted to the output shaft through the chain. And as you can see that the sprockets have the teeth, and those teeth are rigidly sitting on the slots of the chain, and the transmission is made, power is transmitted from the input to the output. So, why we call it a positive? Because in this case the slip between the sprocket and the chain is eliminated. There cannot be any slip like in case of the belt drive, as we have seen that there is a possibility of slipping, the belt may slip over the pulleys. So, here there is no possibility of slipping. So, therefore, this kind of a mechanism is called the positive mechanism. Now, if we drive that, you can see this, that this is the, as I said, that this is input shaft, and when it is driving, so both the direction of rotation of the input sprocket and the output sprocket is the same, okay, because it is like the straight belt that we have shown in the belt drive transmission. And here, of course, these chains, they normally do not come as a cross chain like in case of the cross belt, because of the construction itself, because here it is almost not possible. This is again the transmission is made from the input shaft to the output shaft through the chain and the sprocket. All right. So, this mechanism, it is another mechanism for transmitting the power from the input to the output shaft through the Geneva mechanism. And Geneva mechanism is one of the most popular mechanisms when you have to transmit the power continuously rotating input drive, input shaft, when it transmits power to the output shaft, which should be rotated not continuously but intermittently. Okay. So, as you can see here, this is the entire thing is the Geneva mechanism. This is the Geneva wheel, and this is the pin. Pin is sitting on this disc, and this disc rotates continuously, and while rotating, this pin goes inside the slot of the Geneva wheel and comes out, and during that movement, as you can see, there is one movement or one indexing of the Geneva wheel. As you can see, it is entering and coming out, and in that case it is moving from here to here. Okay. So, it is then indexing when you need the output shaft to index, and the transmission is the continuous rotation of the input shaft. This is the input shaft. The pin comes in and goes out of the slot of the Geneva wheel. In that case, it is coming from one position to another position. Okay. Now, where this kind of mechanism can be used? Let us say we are having that automatic assembly. Okay. So, the table on which the automatic assembly is made, that table has to index from one position to another position for positioning the sub assembly against the workhead on which the operation will be performed. Now, when it is coming to one particular position, in that position it needs some time for the operation to be finished. So, that time is the time when the pin is rotating from here to here, all right, from one slot to another slot. Then when it is entering into the slot and coming out, during that time the sub assembly on that plate, let us say that plate is driven by the Geneva mechanism like this, that plate will be rotated, that is indexed from one position to another position, and the another sub assembly is coming to the particular position where the processing will be performed. So, in those kind of movements, the Geneva mechanism is very effective in transmitting the power. So, here what happens is that this is the input shaft on which the pin is mounted, which is rotating continuously, and once again while rotating continuously the pin goes into the slot and comes out when the Geneva wheel moves from one position to another position. Okay. So, let us assume that each of these position is a position where the sub assembly is to be indexed, and it has to stay for some times for the assembly operation to be performed. So, that time is the time which is called the dwell time in engineering, in the technical term. So, this is effectively, it can be done by Geneva mechanism. Only thing here, as you can see the mechanism, the negative points are that here the pin is taking the entire load, all right. Entire load, I mean to say that this Geneva mechanism on this shaft, okay, on this shaft the output shaft is located, where you have a table, and on that table you have the heavy machinery, let us say heavy sub assembly, let us, okay. So, sub assemblies will be located on this directly, all right, on this position, and here we will have the machines. So, machines are not located on the Geneva wheel as it is, but the sub assembly has to be here. So, the load of the sub assembly will be on this Geneva wheel, and with this load this pin has to be able to move that much load from one position to another position. Okay. So, the pin is becoming in this case the weaker point. In for any reason, if the pin breaks, in that case the mechanism collapses and it cannot work, as you understand. That is the first drawback of the Geneva mechanism. The second drawback of the Geneva mechanism is the number of stopovers. Let us say here in this we have the 1, 2, 3, 4, 5, 6. So, there are 6 positions here, all right, and this number is limited in case of the Geneva mechanism, otherwise the entire Geneva wheel will be very large. So, the number of stopovers is normally 8, that gives the restriction on the working of the Geneva mechanism. If you need to have more than 8 or larger number of the stopovers, in that case Geneva mechanism cannot be effectively used, because the diameter of the Geneva wheel, this diameter will be very large. So, the next mechanism that we are going to see here, this is the rack and pinion mechanism, and rack and pinion mechanism, as you understand that this is the rack, okay, and we are going to show you in the lab how these rack teeth are ground, okay, are made, all right, and the pinion is inside, we will show it. Let us start the mechanism, and you can see that this is being taken out, all the parts are being taken out. This is the rack, okay, and inside that there will be a pinion, this is the pinion, all right. So, the pinion is rigidly is connected through the teeth with the rack, all right, and if this is rotating as an input shaft, as an output shaft on which the racks are cut, this, so that will be rotated. So, now here what happens is that the rotation is the rotation of the pinion is the circular movement, and the movement of the rack is the linear movement. So, here we are transferring the rotational movement to the linear movement. So, this is an advantage here, that this can be both way. That means, if it is if the input shaft is rotating clockwise, then this will be moving from this side to this side, and if it is moving to the anti-clockwise direction, so it will move, rack will move from here to the other side. Okay. So, this is the advantage, and since it is a positive drive because there are teeth in the pinion and the rack. So, therefore, here the torque carrying capacity of the rack and pinion will be more than in the case of the, for example, belt drive. Okay. So, belt drive particularly for the flat belt, okay, those are used normally in case where the torque carrying capacity or the torque required to be transmitted is less. But in the case where the torque required to be transmitted is high, in that case the positive drive has to be used. For example, in this case, as you see, the rack and pinion. Okay. This is another mechanism. This, as you know, this is the gear train. So, here all the gears are the spar gears. Now, there are 3 shafts. One can be considered to be as the input shaft, and this shaft on which this gear is mounted can be considered as the output shaft. So, the transmission is made, the motion is transmitted, power is transmitted from the input shaft to the output shaft through an intermediate gear. Okay. Now, the intermediate gears, they are made or they are required for 2 reasons particularly. Like here in this case, if the distance between the input shaft and the output shaft is larger than the sum of the radius of this gear and the radius of this gear. Okay. You understand that. So, if it is more, in that case there is an intermediate gear which is required. Second reason why the intermediate gear is required is that when the direction of the rotation of the input and the output shaft should be different. Let us start this and you will understand that. So, here as you can see that when this gear is rotating in this direction, the same direction this gear is rotating, all right. This is because of the intermediate gear, because when the input shaft is rotating in this direction, let us say in the anti-clockwise direction, in the clockwise direction the intermediate gear will be rotating, and then in its turn the intermediate gear is coupled with the output gear, which will rotate the output gear in the opposite direction. So, this is in difference with what we have seen in the case of the belt drive. Okay. So, as you can understand that here we are making the rotation, the direction of rotation of the input gear and the direction of the rotation of the output gear as the same, and if that is the requirement, in that case we have to have an intermediate gear, as you can see here. All right. Okay, and the next, as you can see here, is the worm and worm gear. This is very effective in 2 ways. One is that here the transmission ratio can be up to 1:40. So, you can change the rotation, and the difference in rotation between the input and the output shaft can be up to 40 times. Okay. And this is very highly unlikely that you can get this kind of a transmission ratio in case of a gear transmission ratio or the belt drive. All right. So, here this is the worm, and the worm it is called because of the kind of spiral that the thread kind of a spiral teeth that the shaft is having. So, this is the worm, and this is connected with the worm gear, and worm gear because it is coupled with the worm. All right. Now, what is the shape of the worm gear? Worm gear shape will be shown here. So, as you can see that this is the worm gear, where you have a kind of a semicircular shape of the teeth. It is not exactly the straight teeth. Okay. Now, these are the shafts, both of these shafts will be mounted on the bearings, and the bearings will be mounted on the housing. This is the housing for the worm and this is the housing for the worm gear, all right. The entire thing is a worm and worm gear mechanism. Here you can see the level of oil, and it has to be dipped into the oil because of the high torque which is being transmitted, that creates high temperature. This is the input drive that drives the worm, okay, which is on that shaft, and that will in its turn drive the worm gear, and on this shaft at the output we can have a pinion, okay, here, or the sprocket and the chain, and this will rotate then another shaft, okay, and that will be the ultimate output shaft. Let us say here we have the output shaft. So, in case of worm and worm gear only, the worm can be considered to be as the input shaft and worm gear is the output shaft. But from the worm gear, the another transmission is taken through the chain drive, okay, and then finally the output shaft which is mounted on the sprocket, output sprocket, that can be considered as the output shaft, okay. So, in this case the basic advantage of the worm and worm gear, I said that this can be 1:40 transmission ratio, and another advantage of the worm and worm gear is that it has a self locking, in the sense that if you rotate the worm gear will be rotated, but as we have seen in all other cases, that in all other cases when the output shaft is rotated, the input shaft can also be rotated. So, input and the output shaft can be interchanged if it is required, in the sense that what you are calling as the, for example, here in the gear transmission, here we considered this is to be input shaft, but this can also be considered as an input shaft. How does it matter? Meaning that you make the prime mover drive this gear, and then from this gear you take the output transmission or the output torque. But in case of the worm and worm gear, this is not possible, meaning that only the transmission can be from the worm to the worm gear, but you cannot rotate the worm gear and then the worm will not rotate. If you rotate the worm gear shaft, then the shaft on the or the shaft with the worm will not be rotated. Now, this has a certain advantage. Let us think of a crane. Okay. The cranes, you know that they can lift very high, very heavy weight. So, when it is lifting the weight, and in case the power fails, okay, if you use the gear transmission for lifting that, in that case it can the entire load can fall, all right. In those cases it is very important that if the power fails, suppose the electricity goes off or for any reason the whole thing is jammed, in that case the load should not fall, it should stay there, all right. So, in this case that is what it will happen, that if the input is the worm, okay, so you are rotating with a machine, your motor with you are rotating the worm and the worm gear is rotating, but if you stop rotating that, then the worm gear will not rotate in its turn the worm. That is what I am saying by falling the why this can fall. The load may fall from the crane when the worm gear will be able to rotate the worm, okay, or the output shaft would be able to rotate the input shaft. In case of worm and worm gear, since it does not happen, so therefore, this is self locking. This also you can see in many the pulling doors, for example, that if you pull the door, okay, from the top, so at any level it can actually stay, it will not go back if you leave it. So, these are the worm and worm gear. Also, of course, where you need the very high torque to be transmitted. Well, these are basically the transmissions that I wanted to tell you, and through these mechanisms, mostly in mechanical engineering you will see that the transmission is made, the power is transmitted from the input shaft to the output shaft. Okay. So, once again it is we have shown you the belt and pulley, then with the cross belt, okay. Then we had the chain and sprocket mechanism. I have shown it to you. We have seen the gear mechanism. We have seen the Geneva mechanism, and finally we have seen the worm and worm gear. So when we will go to the lab, I will once again show you that how these mechanisms are used in the in different kind of machines. All right. So now in the next slide you can see that hand tools and measuring equipment you might encounter in the lab when we will go. So those instruments we will show it to you, we will describe each of these instruments, how they work and in which cases they are utilized. So I will show you one by one. Let us say here what you see is the bench vise. Most of you must be familiar with all of these equipment. Okay. So all these equipments which are shown here in this slide, these are used in the fitting shop. All right. Here is the vise. So this is called the bench vise because it can be fitted in a bench. All right, on this table in this particular case, and in that case this jaw is fixed and this jaw can be moved on the lead screw that is here in the middle, and those two are the supports. Okay. If you rotate the handle here, by rotating this handle you are rotating the lead screw, and this will be working as a screw, as a nut, and this nut which is the jaw, this will be closer to the other jaw, and in between you can actually fix a part. Let us say this is a workpiece, square workpiece, round shape workpiece, whichever workpiece you need to file for example, or drill a hole, okay, and so on, or cut. So you can see these kind of bench vices, these are used in many places, even outside you can see on the road people, I mean workers, they are working on this. These are very handy and very effective in clamping the workpiece in a certain position. Here you can see that this is a hand vise. So this is handheld. The purpose is the same, that is to clamp a workpiece, okay, or a part in between the jaws. So here you can see the jaws are like this. So you can rotate this handle. This is the lead screw in this case. This is the support, and these are the jaws. Okay. So these jaws will be moving, and one will be the fixed jaw like in this case, and the between the fixed jaw and the moving jaws the part will be clamped. All right. Now this is the pipe vise. Pipe vise is also very popular. You can see on the roads where the workers are cutting the pipes or making thread on the pipes, they have to be mounted on the vise, so that there is no movement of this with respect to the tool that you are using. So here also there is a lead screw. This is the housing of the vise. This is fixed bed, and this is movable. Okay, this is movable. This is rigidly attached at the end of this lead screw. On the other end, the lead screw has a handle. This handle, using this handle you can rotate the lead screw. Here inside this is a threaded hole. Through the threaded hole this lead screw is rotated, and this will go up and down. This jaw will go up and down, and within this space then the pipe, there is an attachment for the pipe. Okay. These two attachments are fixed, rigidly fixed with the base and with the movable jaw, and within this fixture, okay, the pipe will be fixed, pipe will be clamped by rotating this handle, and the pipe can be cut or the thread can be made on this pipe. Here you can see there is a series of files, and those files are required to file the surface, that is to remove the excess material, and the material removal rate is smaller of course, and to of course in some cases to increase the surface finish, okay, to make the surface finish better. So here you can see that this is a hand file, this is a flat file, this is a half round file, this is a round file, square file, 3 square files. So, by the name you can find out that a hand file is normal file which you can see that you use for flattening or for filing the flat surfaces mostly. We will show you in the lab how these flat files or how the filing can be made properly. Here this is a flat file, okay. Flat file and hand file more or less their purpose is more or less the equal. This is a half round file. So, half round file will have the purpose of flat file as well as the flat surface as well as the round shape holes or slots, for example. Round files, they are exclusively used for the for filing the inside of the hole, and here you can see all these are given as a sectional view. For example, the hand file sectional view will be like this. If you make a section along this, the section will be like this. Flat file section is here, half round file section is like this. This is the round file. As I said that round files are normally used for filing the internal hole of an internal hole. This is a square file. This you can see the cross section, and this is the 3 square file. That means here that is called the 3 square. This is a triangular actually shape, okay, and it has certain purpose of filing the square holes, for example, where you have the edge and this edge will be coincided with this edge here, okay, and there the 3 square files are used. Here you can see the file card. So, this is the wooden file, and on that wooden file different kind of different types of files can be mounted. Since it is on the wood, so it can be removed and another type of file, another type of card can be mounted here. This is the hacksaw. Hacksaw is this is the handle, this entire thing is the handle, and this is the saw which is mounted between these two with the screws. This can be removed, and if the saw is broken or the saw is worn out, another saw can be mounted here. These are the hacksaws. These are normally, this is the one which can be mounted here. This is one hole goes in here and the another hole on the other side will goes in here, and it can be tightened, right. This is the normal hammer, so that you can see. Other equipment or other instruments or the tools, these are drill twist. Now, twist drill, okay. Now, these are the drills, these are called the twist drill. There is a 2 different drills are shown here, one whose diameter is less than the other one, both are twist drills. Now, in this case you can see the this is the portion where it will be drill will be used, and as you know the drill is used to make a hole, okay, to drill a hole in a metal surface normally. So, this drill has to be mounted on a chuck, okay, or a drill holder. So, this is the shank, this is the shank which is used to mount the drill in the drill holder or the drill chuck, all right. In this case you can see that this is the cylindrical shank, and in this case for this drill where the diameter is more than the previous one, this taper is the Morse taper, all right, and this holder for this kind of a drill will have also an internal hole which will have a tapered hole, and that internal taper will also have a Morse taper. So, that when this drill goes in, okay, the internal taper of the Morse taper of the drill holder holds this drill through the Morse taper, external taper that the drill has. That is it. There is nothing else in between this shank and the holder. There is no screw which needs to be tightened, which needs to be used for tightening. So, it is the torque when it will be transmitted from the chuck to the drill. It will be only through the friction between the Morse tapers, that is the external taper of the drill and the internal taper of the drill holder or the drill chuck. In this case, since the torque carrying capacity of this drill is less because the diameter of the drill is less, so the hole that will be drilled will not be of larger diameter, this will be of this diameter. So, therefore, the torque which to be applied on this for drilling the hole will not be so high. So, therefore, the shank is made as a cylindrical shank, and that shank can be mounted on the holder, not through the Morse taper, but through some other mechanism which is applied on the cylindrical shank. So, in particular normally there is a groove and there is a spring loaded ball. So, that spring loaded ball will be just fixed in the internal groove and the spring loaded hole and the hole which is made in the tool holder. So, this is just a snap fit, I mean snapping the drill into the tool holder. Here you can see the counter bore drill. Counter bore drill is the drilling of two different diameters of the hole. So, here you can see the diameter of the drill is different than the diameter of the drill here. So, this drill, entire drill, when it is driven to the workpiece, there are two diameters will be held together, and the diameters of these two holes will be different. Okay. So, two holes of different diameters, which are the counter bore drill. Counter sink drill, this is as per the configuration of the drill, the drilled hole configuration will be the same. Okay. Counter sinking is required when you have a particular counter sunk head of a bolt that has to sit in this in the threaded hole. So, you make the hole with the help of a counter sink drill, all right, and then you tap that drill, that means you make a thread. So, that within that hole, within the threaded hole, the counter sunk bolts can actually go. There are particular type of counter sunk bolt. So, that we will show you in the laboratory when we will go what kind of screws are there which are sitting in the counter sunk holes. Here you can see that this is a hand reamer, this is a machine reamer, and this is an adjustable reamer. Okay. Now, the reamer first of all is used to after drilling the hole, some bars will be there will be some surface roughness, all right. So, mostly to increase the surface roughness, to make the surface roughness better, the reaming process where the reamer as a tool is used, particularly not to remove the material as such, but to increase the surface finish, for making the surface finish better of an internal hole. So, these reamers can be of different kind. This is the hand reamer, where the reaming of the hole after it is drilled has to be made by hand. That means, there will be holder. Okay. You can see the holder here, for example. Okay. That is called the tap range. In the tap range, you can actually put the hand reamer, and at the end of the hand reamer, here there is a square cross section. This square cross section part, which is at the end of the hand reamer, it will come in here, fit in here, and then with the help of this tap range, okay, where the hand reamer will be put here, hand reamer will be held here, that can be used for making the hole by hand. All right. So, of course, not making the hole, but reaming the hole, better to say the reaming the hole. These are also used to hold the taps. I will come to the taps. Okay. In the taps also you have the square cross section at the end of the tap, and this part will be held here in the tap range, and then this handle, using these handles by manually, you can actually make an internal thread with the taps. So, these taps are of course, they are different types. This is the starting tap, this is the intermediate tap, this is the finishing tap. Now, the tapping, as I said, is made to make the internal hole. So, first you drill the hole, then you ream the hole to remove the bars and to make the surface finish better. Then you use the starting tap. Okay. Starting tap is when you are in one word, when you are making the thread in a roughing process, that is the surface finish is not very good. Then you are using an intermediate one. So, you are increasing the internal diameter of the thread a little more. So, little more material will be removed, but it is still not the final thread, that is not with the complete surface finish which is required. For that you need to have the finishing tap, and all these processes, how these 3 taps are used in a different way, we will demonstrate in the lab, and you will see that how the holes can be tapped, that means how the internal diameter can be internal thread can be made with the help of the taps. So, here you understand that similar to the hand reamer, the machine reamers are used to ream the hole, or for the reaming process of the hole with the help of the machine, and those machines will be drilling machines, of course you understand that, because in the drilling machine the spindle rotates where the drill is fitted, okay, and to drill the hole. When the rotation and the thrust force will both are imparted on the drill, and instead of drill, if you put the reamer, machine reamer in the drilling machine or the drilling spindle, in that case the drilled hole can be reamed, that means for the better surface finish. This is adjustable reamer where you can adjust the height of the reamer, the length of the reamer, okay, but purpose is the same. This is also used either mostly in case of the machine as a machine reamer. Okay. Here you can see the die. This die is used to make the external thread. Okay. So, these are the taps which are used for making the internal thread, and the dies are used to make the external thread. So, we have the die nut. This die nut is made inside this die, and the entire thing is used to cut the external thread. Here you can see the chisels, and the chisels are mostly used in case of the wood, when you are processing wood, but in some cases, for example, you want to cut the small thin sheet of aluminum, okay, or a thin sheet of metal, mild steel sheet, very thin one. So, those are, then in that case the chisel can be used, apart from using it mostly in case of the wood. So, you can see the chisels being used by the carpenters, those who deal with the wood works. Okay. Next you can see the measuring instruments, measuring equipment. This is the ruler scale. Here you can see the vernier caliper. Vernier caliper is a precise instrument to measure the diameter of a cylinder, or the external diameter of a cylinder, or the internal diameter of the hole. So, external diameter can be measured by these jaws, and internal diameter can be measured by these jaws, and this is the scale. So, here we have a linear scale, main scale which we call it, and I will show you when we will have the metrology lecture series. I will show you we will come back to the vernier caliper again, and I will show you how the least count of a vernier can be found out. In that case, I will show you both the scales, the main scale, use of the main scale and the vernier scale to find out very precisely up to 2 to 3 decimal levels how to accurately find out the diameter. Okay. Either it is an external diameter or it is an internal diameter. It is not only the diameter. For example, if you have a square, if you have a cube, okay. So, to measure the distance between the two faces, you can also use the vernier caliper, you understand that. Here you will see the caliper in the lab, and you will see how the vernier caliper can be used. Similar to that, for measuring the outside diameter, okay, we can use the micrometer, and here you can see in the micrometer the display which is digital. So, in that case you do not have to read the main scale and the vernier scale and find out accurately what is the measurement, but in this case the measurement can be seen in the display of the micrometer. So, this is called the outside micrometer, because the outside diameter can be found out. So, all the descriptions are given here, even the dimensions are given here, you can see that. Okay. So, this is the normal micrometer which is used in the metrology lab or the machine tool lab. Okay. We will see this. Here we have the inside micrometer. This is outside micrometer because, as I said, that outside diameter can be measured. This is the inside micrometer, where like in the case of the vernier caliper with these jaws, here the inside diameter can be measured with the help of these two jaws. Okay. This jaw is the fixed jaw in this case, and this jaw is movable jaw. This can be moved with the help of this screw, all right. And there is a main scale and there is a vernier scale, circular scale, all right. With the help of that, these scales, you can find out what is the internal diameter of the hole. Now, this is the depth micrometer. Depth micrometer is that here this rod can be moved up and down with the help of the screw here, and this will be at the base, and this distance between this point, this base, and this point, which will be movable, the distance will show in this scale, and you can find out that what is the height. Okay. For example, if a cube again, so if you want to find out the height in this, so that you can find out, all right, with the help of the height micrometer, or sometimes it is also called the height gauge. This is the dial indicator, dial gauge, and you must be familiar with such kind of dial gauges, you must have used it. So, here we have a base which can be mounted on a plate, okay, which is the metallic plate, let us say a ferromagnetic materials plate, and there you can have this is a magnet. So, you can activate the magnet and deactivate the magnet, depending on that. This base will be sitting rigidly or loosely, all right, and here you have a dial gauge. So, that dial gauge can be a fine dial gauge or a rough dial gauge. So, that depends on what will be the least count, what is the minimum distance between the two graduations in the dial, okay, dial indicator. So, this least count we will talk about when we will discuss the metrology part. So, here there is a stylus, the stylus is spring loaded, and this stylus can go up and down, all right. Depending on that, this is the needle, that needle can move along the dial of the dial gauge, and it will indicate the exact movement of this. So, this movement of this stylus, this movement is not much of that, because these are here the entire thing may be a few millimeters only, and this movement is highly amplified for the rotation of the needle. Okay. So, that a little movement of the stylus can be felt by the needle, and the needle will show exactly the measurement. This is called the outside caliper, and that means first you find out what is the distance between the two jaws, that is what is the, for example, again the cube, what will be the distance between the sides, and then from there you can find out through the scale, a linear scale, that what is the distance. And this is similarly the inside caliper, and inside caliper will measure the inside hole, the diameter of the inside hole, and here there is no scale, of course, directly you cannot find out. So, you first make this inside caliper measure the internal diameter, and then you take that and find out from the scale what is actually the value. Okay. So, here there is no, these are simple gadgets, simple mechanisms, okay, by which you can find out the diameters, internal or external, or the distance. Here you can find out measuring and marking equipment. These are the dividers, like in the geometry box that you get. This is the surface plate, this is absolutely flat, all right. This is the V block, and the V block is used to place the cylindrical part, so that the cylindrical part axis is coaxial, remains coaxial. Okay. So, if you rotate if you put a cylinder here, and if you rotate that cylinder, in that case you can make sure that the rotation is around always around the axis of the cylinder. All right. Here this is the bevel protector. Bevel protector is used for measuring the angle, okay, accurately, and again depending on the least count of the bevel protector, you can measure a smaller angle or a larger angle and so on. This is a scriber to scribe the part, to mark this. This is engineer's try square that many of you might have used to make the drawing in your classrooms. This is the wire gauge. Wire gauge has different profiles with the different diameters, from very small to very large. You can see these holes. So, the wire is passed through one of these holes, and where it can be fitted, that diameter is written here. That will be the diameter of that wire. So, quickly to find out what is the diameter of the wire, you put this here on the wire and find out what is the diameter. This is called the center square. So, this is the center square which is used to find out again the angle and the exact square. This is movable, this can be adjusted. This will show you in the laboratory. This is the center punch. So, here you can actually punch it before you drill the hole. Okay. So, this is required because when you are drilling, actually the drill may not touch the center exactly if it is not marked. So, to mark the center of a particular hole or a particular place where you are going to drill, you have to actually put a mark here. These are the universal marking surface gauge. You can see that here it will be mounted on the plate, let us say on a flat plate, and this is the marker, okay, scriber kind of thing. So, this will scribe the surface. This is a ruler, and this ruler will give you that what is the distance, what is the height. Okay. Here you can see the combination set. The combination set will show you, otherwise you will not simply, it will not be understood how this combination set uses. This is used for making different kind of measurements, that is why it is called the combination. Here you can see the striking tools, and these are the hammers. So, these are normal hammers, and these are very popularly used in the households also. This is the angle plate. This angle plate will exactly tell you whether there is a 90-degree angle between the two faces of a particular, let us say, prismatic job or square job and so on. So, these are the basic measuring equipment, basic measuring devices which are used in any lab. Okay. Either it is in the machine tool lab, or it is a metrology lab, or it is the machining lab. So, when you will go to the laboratory where we will show you different kind of machines, in the lab there are conventional machines like turning lathes, there are milling machines, there are drilling machines, there are shaping machines, and we will show you there are grinding machine also. We will show you how each of these machines can be operated, how a part can be fabricated on these machines, and how for that what are the steps which are involved in these machines. So, all these devices, which measuring devices that I have shown it to you, the transmission mechanism or the power transmission devices that I have shown to you, these are all used in these laboratories, and you will see those devices and those equipment in the laboratory when we will go there. Thank you. The rest of the things we will discuss in our next part.